Welcome to the Virtual Public Information Center, or PIC, for the Sawmill Creek Erosion Control Project, Folkway Drive to Erin Mills Parkway, Municipal Class Environmental Assessment, or EA. Thank you for your interest in the environmental assessment of the Sawmill Creek Erosion Control Project that is currently ongoing from Folkway Drive to Erin Mills Parkway in the City of Mississauga. This presentation will discuss the scope and nature of issues that have been identified in this area, as well as the different solutions or alternatives that are being considered. Lastly, you will learn about how you can voice your questions and concerns through the study process. The City of Mississauga identified this section of Sawmill Creek as a high priority area in need of rehabilitation based on the severity of creek erosion and risk to infrastructure. Key concerns include damaged gabion baskets, broken concrete, bank erosion impacting vegetation and the adjacent park trail, exposed and damaged pedestrian bridge footings, and the deposition and vegetation growth within the creek. The City is initiating a municipal class environmental assessment under Schedule B to investigate the causes, extent, and mitigating alternatives of the issues identified in this area. The municipal class environmental assessment process provides opportunities for the public and stakeholders to bring forward questions, concerns, and feedback throughout the study period. This process ensures that all reasonable alternatives are considered and that a preferred alternative be selected for implementation such that it would have net positive or minimal negative impact to the surrounding environment. The information shown on this slide provides the key details for characterizing site geometry, geotechnical, natural heritage, archaeological, built heritage, social, and geomorphological background conditions. Sawmill Creek originates at Folkway Drive and flows southeast, joining with the Credit River at Mississauga Road and Dundas Street West. The study area is located within the City of Mississauga's Sawmill Valley Trail area and includes the Sawmill Valley Trail network. Existing conditions of Sawmill Creek through the study area include the occurrence of bank protection, or bank hardening, along the channel, with 39% of the channel banks being protected through the study area. There are 19 grade control structures, or weirs, along the watercourse. Most bank protection and grade control measures through the study area are considered to be in a deteriorated state, and some have completely failed. The hydrology of Sawmill Creek reflects the urbanized condition of the watershed and the limited stormwater management measures that are in the watershed. Geomorphically, Sawmill Creek would be considered a meandering channel with a pool riffle sequence. However, much of the channel bed and banks have been modified with controls to limit incision and lateral migration. 6 reaches were defined based on characteristics of the channel bed profile, channel dimensions, and erosion control measures. Erosion and evidence of channel adjustment through channel widening, scour pool development, and outflanking or undermining of erosion and grade control measures is abundant throughout the entire channel within the study area. A Stage 1 archaeological assessment was conducted by Timmins Martell Heritage Consultants. The Stage 1 report indicated that, within proximity to the study area, there were 2 previously identified archaeological sites, an area of early 19th century settlement and an early historical transportation route. A Stage 2 survey has been recommended to be completed for the grassed and wooded areas, which are approximately 23% of the study area. A multi-use trail runs along the extent of Sawmill Creek. The pedestrian pathway network includes 2 bridge crossings over the channel through the study area. The trail and connecting pathways serve to link communities on both sides of the creek, as well as the parkette located midway through the study reach. A natural heritage assessment was completed to determine the potential impacts of the project on the natural environment. 5 vegetation communities were delineated, including meadow, woodland, and deciduous forests. Vegetation consisted of native and non-native species. From an aquatic habitat perspective, seasonal fish passage barriers were present in the form of failing weirs, log jams, and erosion areas. A large amount of invasive species exists along the channel, and fallen trees or limbs can impose a risk to channel blockages and accumulation of woody debris. This slide contains aerial images demonstrating study area conditions in 1954 and 2019. A comparison of the images enables an understanding of changes in channel conditions, vegetation, and overall study area features through time. Based on a detailed historical assessment, extensive urbanization occurred during the 1970s in the study area. Sawmill Creek has been realigned through the study area as a result of channelization project conducted between 1975 and 1977. The vegetation communities of the area reflect these historical changes. This slide provides a summary of the systemic issues and concerns identified through the EA process. These issues are considered to be more widespread through the Sawmill Creek study area, rather than being of local concern. The systemic issues identified include engineered channel conditions, the deteriorated condition of existing bank protection and grade control structures, channel bed and bank erosion, the occurrence of erosion on both channel bed and banks throughout the study area, debris accumulation, the widespread occurrence of large woody debris accumulations within the channel, ultimately promoting ongoing erosion and channel adjustment processes. Infrastructure. Concerns of the integrity of the existing infrastructure within the study area were identified, including potential exposure of sanitary sewer crossings, deteriorated pedestrian bridges, and risk to the multi-use trail due to ongoing channel erosion. Invasive species. These species were identified throughout the Sawmill Creek study area, including buckthorn and garlic mustard. Aquatic habitat. The occurrence of barriers to fish passage, including debris accumulations and grade control weirs, were present throughout the channel. This slide lists the various opportunities that can improve or enhance existing conditions. These opportunities include improve the native species composition through the removal of invasive and non-native species and replacement with native trees, shrubs, and herbaceous species. Enhance morphological form and function of the watercourse by re-establishing natural channel conditions to re-establish dynamic stability. Removal of erosion and grade control features along the channel where feasible to re-establish natural sediment transport and channel function. Manage and/or remove large woody debris jams which are causing bank erosion, channel widening, and local backwatered conditions. The management or removal of debris within the channel would also improve fish passage. Reconnect the channel to the adjacent floodplain in the downstream portion of the study area to reduce the ongoing bank erosion due to containment of high energy flows within the channel cross-section. This slide lists the various constraints through the Sawmill Creek study area that need to be considered when developing solutions for existing issues and concerns. These constraints include subsurface infrastructure, including sanitary sewers and water mains, which occur adjacent to, below, or in proximity to Sawmill Creek, which limit alternatives and require protection. Multi-use pedestrian pathway located within the Sawmill Creek Valley system limits the channel design opportunities spatially, that is, the lateral extent within the study area. Butternut tree species observed along Sawmill Creek should be preserved where feasible in the selection of the preferred alternative. Suitable bat habitat, including cavities and tree snags, were observed within the study area. Tree removals should be selective in order to avoid potential impacts to bat habitat. 4 locally rare vegetation species were recorded within the study area and should be preserved or relocated where feasible. As a part of the environmental assessment process, several potential alternative solutions or approaches are needed to address the identified erosion issues and concerns. Each alternative must represent a viable solution. Alternatives must be constructible, provide an effective method to mitigate the erosional concerns, and shall be such that any impacts are mitigatable. For the Sawmill Creek Erosion Control EA, 4 alternative solutions were developed to address existing issues and concerns. Each of the following slides includes a plan view of the alternative, conceptual cross-sections, and concept channel profile configurations. This slide summarizes key components of Alternative 1, do nothing. In the do nothing alternative, no action is taken to address the identified issues. This alternative is always considered during an environmental assessment in order to assess the impact of taking no action. The do nothing alternative would result in the following: continuation of ongoing channel processes that are leading to the deterioration and failure of erosion control and grade control measures. Continued bank erosion and downcutting or scour of the channel bed, which will cause further exposure of underlying glacial till material. Continued risk to existing infrastructure due to ongoing processes, which includes bridges, sanitary sewer crossings and manholes, and the pedestrian pathway, which may lead to eventual failure. There would be no direct impact to vegetation through Alternative 1. However, continued failing of trees into the channel cross-section due to ongoing bank erosion processes is anticipated. This would result in more accumulation of debris within the channel, further promoting erosional processes and causing barriers to fish passage. This slide summarizes key components of Alternative 2, spot repairs. Local channel repairs and enhancements would aim to repair or replace, where necessary, failing erosion protection and grade controls, and remove accumulations of debris from the channel cross-section. This alternative maintains, or nearly maintains, the existing footprint of the channel. Features of the spot repair alternative would include the following: replacement of the 2 deteriorated existing bridge crossings. Areas of erosion and undermining of the bridge crossings would be addressed. Removal of the failed or outflanked gabion grade control structures, or weirs, and replacement with natural stone riffles. Removal of dead or unhealthy trees and channel debris. Placement of natural stone or woody material to provide erosion control in vulnerable locations, along pathways, slopes, or in proximity to buried infrastructure. Impacts to vegetation and vegetation removal are associated with construction and would be limited to areas of construction or access points. Restoration would occur in areas of vegetation impact. This slide summarizes key components of Alternative 3, full restoration. Full channel restoration would be based upon the principles of natural channel design, with the objective that the channel will function dynamically to manage the erosion and sediment transport processes, as well as the respective flow regime which result in the watershed hydrology. The full realignment would focus on maintaining and enhancing the existing geometry of the channel which has developed through the years while removing the failed erosion control systems and mitigating the risk to the built and natural infrastructure. Features of a full restoration alternative would include the following: channel planform and bed profile enhancements using natural channel design approaches. Removal of failed erosion control systems, gabion lining, and gabion weirs. Repair or replacement of existing pedestrian bridges. Protection of at-risk buried infrastructure, including storm and sanitary services. Removal of dead or unhealthy vegetation, invasive species, and debris. Possible removal of vegetation where it would interfere with channel and valley geometry. Installation of fish habitat structures using existing woody material within the channel. Facilitated fish passage with pool and riffle channel geometry. Impact to vegetation and vegetation removal associated with the construction would extend along the extent of Sawmill Creek through the study area. Full vegetation restoration would be required following all removals. This slide summarizes key components of Alternative 4, reach-based restoration. Reach-based restoration focuses on selected reaches within the study area that contain similar physical features whereby a common mitigation strategy can be applied. Thus, any features through the study area that do not require mitigation are not impacted. The features of this alternative would include the following: channel realignment of approximately 400 meters of the watercourse within the downstream area, and floodplain terracing to provide a wider flow path above the bankfull stage. Replacement of the 2 deteriorated bridge crossings. Removal of the failed or outflanked gabion grade control structures or weirs, and replacement with natural stone riffles. Removal of dead or unhealthy trees and channel debris. Planting of native tree species and shrubs. Reconfiguration of portions of the channel using natural channel design. Placement of natural stone or woody material to provide erosion control in vulnerable locations along pathways or slopes or buried infrastructure. The impacts to vegetation and vegetation removal are associated with construction and would be limited to areas of construction and access points. Restoration would take place in area of vegetation impact and removals. The environmental assessment process requires that each alternative be evaluated against criteria that pertain to that specific study. The criteria are intended to recognize factors in each alternative and their ability to address the identified issues. Each of the proposed alternatives were evaluated against the following criteria. Technical criteria, which evaluate measurable impacts such as erosion, river stability, flood risk, slope stability, infrastructure, utilities, and other factors. The technical evaluation has also considered the relative constructability and approvability, or approval from regulatory agencies, of the alternative components. Environmental criteria, which evaluate the impact on vegetation, fish habitat, and terrestrial habitat. Social criteria, which evaluate impacts to social amenities and recreations, temporary construction activities, archaeology, private properties, and public access and safety. Economic criteria, which evaluate the initial capital costs of construction, as well as the long-term operation and maintenance cost considerations of the alternative. This slide provides a summary of the evaluation process for each of the 4 alternatives developed for the Sawmill Creek Erosion Control EA. Key factors of each of the alternatives considered during the evaluation process are as follows. Under Alternative 1, do nothing, benefits included no future construction disturbance and no immediate costs associated with the alternative solution. Challenges included the continuation of erosion and incision along the watercourse, continued deterioration of infrastructure, including bridges, weirs, and channel bank protection, and the continued propagation of invasive species within the study area. Under Alternative 2, spot repairs, benefits included the replacement of deteriorated bridges, weirs, and channel bank protection where deemed necessary, which results in a limited disturbance to the site. Additionally, costs associated with Alternative 2 are considered to be comparatively low. Challenges associated with this alternative include the lack of a holistic channel erosion and incision mitigation plan, as well as the requirement for frequent future maintenance. Under Alternative 3, full restoration, identified benefits included the management of erosional concerns throughout the study area and the removal of invasive vegetation along with native vegetation restoration plans. Challenges associated with this alternative included site-wide disturbance required to construct the full restoration, as well as the comparatively high cost associated with the implementation. Under Alternative 4, reach-based restoration, benefits included the focused improvements to the areas of incision and channel erosion, the replacement of deteriorated pedestrian bridges, and the relatively moderate site disturbance associated with the implementation. Challenges associated with Alternative 4 include the moderate site disturbance and the comparatively moderate costs of the implementation. Upon completion of the Public Information Center or PIC review period, the following steps will take place. The study team will compile and review feedback from the virtual PIC. The team will select a preferred solution and implementation plan. The study report will be finalized for agency and public review during a 30-day comment period, and the city will undertake detailed design of the preferred alternative. Thank you for viewing the virtual Public Information Center of the Sawmill Creek Erosion Control Project from Folkway Drive to Erin Mills Parkway Municipal Class Environmental Assessment. You can find comment sheets on the City of Mississauga's website linked from the page where you found this presentation. The public is encouraged to complete the comment forms and submit them to be considered during the study process. Should you have any questions or concerns, please use the contact information provided on this presentation slide.